Alrighty, so 7.1c lesson. We're going to look deeper into this areas of irregular shapes and bring on this idea of an x. So notice that we've got numeric values here, and now we have a variable. Okay, so that's going to be the difference from the other day, from the last lesson, I should say. All right, use your knowledge of area to find the area of the following shapes. Write an expression to show how you arrived at your answer. Okay, so we know that the area of a rectangle is base times height. And we're going to have 60 times 100 or 100 times 60. It does not matter the order. Remember, multiplication is commutative. So I've got 6,000 meters squared is the area of this guy. So this we're going to do in the exact same way, but this time we've got 60 times x, and it doesn't go any further. Okay, so 60x meters squared is your answer. Suppose you had a 60 by 100 meter plot of ground on which you were going to plant a garden. In the corner of your plot, you want to build a 5 by 8 storage shed. How much area will be left for your garden? Does it matter which way the storage shed is oriented? All right, so let me just get my head around this. I've got my 100 meter by 60 meter, and I'm going to be cutting out this corner here. That's 8 by 5 meters. Okay, so do you oops, sorry guys, I should have that up there. So I've got my big one, 100 by 60, and I've got this little shed in the corner here, 8 by 5 meters. Okay, hopefully you can just see by the drawing, you're going to find the area of the whole thing and take out that little area. That'll be that leftover chunk right here. Okay, so we've got the area of the large minus the area of the shed. Okay, so we're going to do base times height. This is going to be base times height, and this is going to be base times height. So we've got 60 times 100 minus 8 by 5. So 6,000 minus 40 equals 5960. Okay, so the area of the garden will be 5,960 meters squared. Okay, does it matter if your shed is oriented like this, or if you turn it and have 5 down here and 8 up here? Does the area of the garden change? No. So it doesn't matter. If the shed is this way or this way. In terms of the area, it might look different to you, it might look nicer or not as nice, but the area of the garden will be the same. You'll still have to cover the same amount. Okay. Oh, I'm just realizing I should have went this way because this is both B. Okay. Suppose you have a 60 by 200 meter plot of ground in which you're going to plant a garden. You don't want to plant the whole thing, just an area of 8,000 meters squared. If one side is 60 meters, how long will the other side, the 200 meter side, have to be to have an area of 8,000 meters squared? Okay, so it sounds like we're keeping our 60 meters. Okay, and this whole thing right here is 200 meters. Okay, so that's going to be 12,000 meters squared, the area. So we need to find out how much we're going to be cutting off this way to get, what was it, 8,000 meters squared. All right, so we need area equals base times height. Our area is going to be 8,000. Our base, we don't know, but our height is 60. So if we divide by the 60, we would end up with, it's an ugly number, 133. I'm going to come out over here because I'm out of space. B is 133 and a third meters. 133 and a third meters. So we have to kind of back this up. This has to be chucked off, and this is going to be 133 and a third meters. Okay, so this 200 meter side needs to get cut off to be 133 and a third meters to have that area be 8,000. All right, so let me put that answer here in a sentence. So the other side will need to be 133 and a third meters, okay, to have that area of 8,000. All right, what percent of your 60 by 200 meter plot of ground area will be planted? All right, so if we take the 8,000 on this one that's going to be planted and divide it by the whole thing, 12,000, that gets us about 0.66, and it just keeps, that 6 just keeps going. 6 just keeps going. So as a percent, 66 and 2/3%. You could put 66.6 repeating bar, 66.6 repeating bar if you wanted to, of the land is planted. Okay, the next few on the next page here are just kind of some odd shapes, and you're going to use either you can either add these, and you know what, I think I'll do one. You know what, this one is the same thing as this one, but this one has an X. So I'm going to use the same technique. I think for me, I'm going to do this whole thing 7 by 5, and then I'm going to take out this 4 by 2. Same thing over here. I'm going to do this X by 5 and then take out this 4 by 2. It's going to be the same technique on both. You could also draw a line inside here, right here, and add these two rectangles together, or a line right here and add these two rectangles together. Okay, that works great with this one. It gets a little bit more complicated with this one being X. Okay, if you took this as 4, okay, this would be, one of the pieces would be X and one would be 4 minus X. So it gets a little trickier on that one. I would not recommend that way. All right, so I'm going to take the area of the big and then take out the area of the little. That's going to be kind of what my head's getting around right now. So I've got 7 by 5, and I'm going to take off 4 by 2. So 7 by 5 is this whole thing, this whole area, and then I'm taking off this little chunk right here. So 35 minus 8 gets me 27. So 27, we're in yards squared. Okay, that's how you do it if you are all numeric. You have numbers all over the place. Now what happens if we throw an x in? We're going to do the same thing. Area of the whole thing, area of the big minus area of the little. Okay, so this time we've got 5 times x for this whole thing. 5 times x, and we're going to take out this 4 by 2. So this is just going to be 5x minus 8, and it doesn't go anywhere. Okay, those are not like terms. You cannot combine that. So 5x minus 8 needs to be in parentheses because the whole thing is in yards squared. If you did not have the parentheses, you'd be saying 5x of some sort minus 8 yards squared. So it's very important to have the whole thing saying we're all yards squared. Okay, let's get into same idea down here, all numeric, bringing on an x. Okay, and again, I'm looking at this entire thing 100 by 60, and then I'm looking at this 45 by something. Okay, this piece right here, if this is 12 and this is 34, that would be a total of 46. 60 needs to be the whole thing. Okay, so if this whole thing is 60 meters, okay, that little piece right there is going to be, let me see, it's 46, so 14. Okay, 14 meters is that little guy. Okay, so let's go ahead. We're going to do the area of the whole thing. Sorry, the hair kind of stuck on my finger here, and I don't want it there. Okay, area of the big thing minus area of the little thing. So we're going to do 100 by 60, and then we're going to take off 45 by, what did we say, 14. Okay, so this is 6,000, and this is 630 if you pop it in a calculator. I had already done that. Okay, so that would be 5,370. So 5,370 meters squared is the area of this object. Okay, now it actually gets easier if you have an x. It's not as much to compute, okay, as you would notice back up here. It's not as much to compute. You didn't have to do anything more with this. Okay, same thing will happen here. So I'm looking at that little chunk there. Okay, and it's going to be the same thing. This little chunk right here is 14 meters because the whole thing is 60. And we've got a 12 and a 34 piece already. So 14 would be the leftover to make this whole thing 60. All right, so I'm going to do the same thing. Area of the big thing minus area of the little thing. All right, base times height of the big thing. We've got 100 by 60. And area of this little one is going to be 14 by x, or x by 14. So this is going to be 6,000. How funny, I had 600 on my last calculation. 6,000 minus 14x. So please make sure you have your answer in parentheses. The whole thing is meters squared, that whole thing. Okay, let me add a 0 onto this original copy I have here. Okay, cool. All right, now we're going to get into some different looking shapes. Okay, this one says find the area and perimeter. Find the area and perimeter. All right, the last ones, let me just double check. I think we were just finding the area. Yes, area, find the area. Okay. So this is area and perimeter. So we need to make sure we have all sides labeled here. 5x, 7x, 14. This isn't labeled, it needs a label. Okay, well, if this whole thing is 7x, And this up here is 3x. This has to be 4x because 4x and 3x make the 7x. Okay, same thing right here needs to be labeled. If this is 14 and this little piece of it's 5, 14 minus 5, this would be 9. Okay, so the perimeter, start over here for perimeter. I'm just going to start right here and I'm going to walk around and add up. 7x plus 14 plus 4x plus 9 plus 3x plus 5. Okay, all that added together is going to become the perimeter. So let me underline these x terms. Those can be added. So that gets me a 14x. And then let me underline the numeric, the constant terms here. It's going to be 28. Okay, so we've got the perimeter is going to be this whole thing, units of some sort. Okay. All right, so now let's get into our area. Area, again, I'm going to do the whole thing. I'm going to do the whole thing and then I'm going to take out this piece. Okay, you could cut it here and add these two rectangles together. You could cut it here and add this rectangle to this rectangle. There are lots of ways to do this. All right, so let's do the big thing, the big, which is going to be 7x by 14. Minus the little, which is going to be 3x by 9. Okay, so this is going to get me 98x, and this is 27x. That comes out to 71x. Okay, and I'm always getting in the habit of having parentheses around the whole thing. Units squared is my answer. Okay, so I've got my perimeter answer and my area answer. Okay, let's take a look at this trapezoid. Okay, this one just wants the area, not area and perimeter. Okay, remember that the area of a trapezoid, so we know it's a trapezoid because we have one pair of parallel sides. These are my parallel sides. This is a leg and this is a leg. Okay, we know that the height of this, so my base 1 and my base 2 are these guys, and my height comes together with these bases at a 90-degree angle. Okay, so it's 12 is the height. So to recall my formula, 1/2, add the bases together, times it by the height. So let me plug in what should be plugged in. So base 1 and base 2, doesn't matter which one's 1 and which one's 2, doesn't matter. So there's my formula. Okay, I'm going to take half of 12, get rid of that half right now, and I've got 6. 2d plus 6. You guys remember distributive property all the way back in Module 1? That would end up being 12d plus 36. Okay, and this is an area, so we need parentheses around the whole thing with units squared. Okay, this guy, area and perimeter. Okay, let's go around the object and make sure we have every side labeled. All right, so 15x, this needs to be a 7 because this is 7. 5x, 5, we need something here. If this is 5x and this is 3x and the whole thing is 15x, this right here is 7x. Right here is going to be a 5. 3x, okay, so we have everything. All right, let me start right here. I usually mark where I start because otherwise I'll forget, like, did I start there? By the time I get all the way around for perimeter. All right, I'm going to start right here. 7 plus 5x plus 5 plus 7x plus 5 plus 3x plus 7 plus 15x. Okay, so I started here, added this, 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 and this. Big. Okay, so let me underline the terms with the x's. Let's condense this. Let's combine like terms and make this as tight as possible. So we've got 5x and 7x, that's 12x, plus another 3x is 15x, plus another 15x. I'm getting 30x. Okay, and let's underline the constant terms. 7, 5, 5, and 7. 12 and 12, 24. Parentheses around the whole thing, and we are in some sort of units. Okay, now we're going to go ahead and calculate the area. And I'm going to stick with my usual 7 by 15x. That's the whole thing, and then I'm going to take out that piece right there. Okay, so area, I've got 15x by 7. That's the whole thing. And then I need to take out the 7x by 5. So 15 times 7, that's 105x minus 35x. So we're getting 70x. That whole thing is units squared for an area. Perimeter answer up here, area answer down here. All right, number 10 wants the area of this shape. Not the perimeter, just the area. So I'm going to go ahead, I'm looking at, I see a triangle and a rectangle. Okay, so it's important to understand here is the 90-degree angle. Okay, so if this whole thing is 10 and this bottom piece right here is 4, you okay that this is going to be 6 in here? From here to here is 6. From here to here is 6. Okay, let's do the same thing for this. If this is 9x and this piece of it is 5x, are we good that this little piece right here is 4x? Okay, so I'm going to do the whole area needs to equal the triangle plus the rectangle. That's going to be kind of my formula for this one. Okay, so area equals the triangle. Triangle is 1/2 base times height, so 4x by 6. Plus the rectangle is going to be 9x times 4. So this is going to end up being 12x plus 36x, and that is a 48x. I'm going to put parentheses around the whole thing, and I'm going to say units squared. Okay, doing some pretty tricky problems. Okay, the one on the back is even trickier, the one on the last page. All right, we've got this bullseye shown to the right. It's made up of 2 concentric circles. So concentric just means one is a larger version of the other. Okay, the radius of a smaller circle is 4.5 inches, as it's demonstrated here. The larger circle has a radius of 9 inches. So we would need to think of the whole thing would be 4.5 plus 4.5, which is 9. Okay, it says use 3.4 to approximate pi in calculating the area of the smaller circle. So area of the smaller circle is pi r squared. So we're going to have, I'm going to plug in 3.14, it says 2 for pi, and then 4.5 squared is going in. Okay, that gets us this times this comes up to be, let me see here, 20.2 times the 3.14. Okay, and I just reversed them, sorry. 4.5 squared is 20.25. Okay, and then I'm gonna actually make these squiggly because I've already put in my 3.14 approximation for pi up here. And then that comes out to be 63.585 inches squared. Okay, now let's do the area of the larger circle. So we still have the same formula, but this time our radius, let me put 3.14 in here, squiggly lines, approximating already. Our larger radius is 9 squared. Remember the whole thing added together. So this is going to be 81 times 3.14, and that came out to be 254.34 inches squared. All right, now we're going to calculate the area of the space between the smaller circle and larger circle, the outer ring. So basically, you guys, we are finding the area of the shaded. Okay, we did the whole thing, and we're going to take out that middle circle, that small circle, and we're going to be left with kind of like a lifesaver type thing. Two-dimensional, right? Flat. Let me scooch it up so I can write. All right, so this is going to be the area of the large minus area of the small. And we're going to take, there are a couple ways you can do it. You could have taken this 254.34 minus 63.585, and that would have gotten 190.755 inches squared. Or we could be more accurate in the area of the large. The area of the large, this is 81 pi. Isn't this 81 pi? And this is 20.25 pi. And if you treat pi like an x and just do 81 minus 20.25, that comes out to be 59.75 pi. And if you plug in 3.14 for this, you get about 187.615 inches squared. This answer is closest to being accurate as a decimal. This answer is absolutely exact and accurate. This one is the least accurate because we rounded this calculation and we rounded this calculation to get this. So this is like double rounding in it. Okay, so I would accept either one. Okay, my honors students, I would kind of gear towards this being more precise. Okay, but it's okay for our class to take the two rounded values and subtract them. Notice how very close they are. Okay. All right, assuming the dart hits the target somewhere, what is the probability of hitting the smaller circle's area? Okay, well, the smaller circle's area from up here, we're going to take 63.585 and we're going to divide it by the area of the whole thing. The whole thing is this guy right here, 254. 254.34. Now, if you pop that in a calculator, it's about 0.25. So you have a 25% chance of hitting this area right here if you throw a dart, according to the area. Okay, the probability of hitting this outer ring, the shaded area, okay, you're going to take this number right here. That's the outer rings area, 190, that number. 190.755, and you're going to divide it by the whole thing. And that is about 0.75. And wouldn't you expect that to be 0.75? Okay, so if we already found this white part to be 25%, wouldn't that outer ring be 75%, totaling 100% of the whole thing? So 75%. Okay. All right, guys.